Hello everyone, welcome to AGACAD's Floor Plus webinar on framing timber and steel floors in Revit. My name is Povilas, I'm BIM application engineer here at AGACAD. Here we create applications for Autodesk Revit based on the needs of the world's lead BIM practitioners. Our aim is to eliminate tasks that don't create value. AGACAD has developed the widest range of true BIM software in the world. It covers wood and metal framing, precast concrete design, and MEP systems design. Today we're going to talk about BIM solutions called wood framing floor and metal framing floor. They intended for detailed design and detailed design of prefabricated timber and steel floors, floor panels, and sort of panel systems. Wood framing BIM solution for Revit has been recognized as an AEC industry partner solution by Autodesk. Okay, so let's look at the main benefits of Floor Plus. We can auto-generate detailed multi-layered floor framing using predefined or custom rules and templates. We can find structural and engineering clashes, cut and frame openings according to predefined rules. We can auto-generate details to joists or trusses according to predefined configurations. In the pictures, you see some examples of that. Furthermore, you can auto-generate floor layout and split floors into panels for prefabrication. And you can auto-generate floor truss layout as well. What we're going to cover in this webinar, we're going to design and generate floors and multi-layered floor panels. We're going to generate views, drawings, schedules, and produce drawing sheets. We're going to customize and create unique framing configurations, design and generate floor trusses, and a few other things. The result you're going to see is multi-layered floors generated using Floor Plus functionality. Floor truss is generated using combined Floor Plus and Truss Plus workflow. Floors split into prefabricated panels using floor panel layout and a couple of other things. Okay, let's now move to our Revit model. First of all, if you have never used tools for BIM, AGACAD's tools for BIM, once you install the tools for BIM doc, the small tab is going to appear at the top of your ribbon. If you click this tab and then click on Show Doc on your left-hand side, and the doc is going to appear on the right. And in here, if you go either metal or wood framing, in the menu, just look for wood framing floor in this case. Same goes for metal. And you have cut opening, floor panel layout, and a few other items in the package. We're going to mainly focus on wood framing Floor Plus and Truss Plus. We're going to use cut opening a little bit as well. Okay, so if we just click on Floor Plus and then click on this small button, Floor Plus is going to appear at the top of the ribbon if you just pull it out to your screen and just can close the dock. Okay, so here I have laid out a few sort of sample floor types with set with different configurations for framing. So I'm going to show you how to frame simple floor type where we're going to go to a bit more complex, and we're going to look at metal framing as well. Okay, so let's just begin with this one. So the thing to know about using Floor Plus or any AGACAD tools, they all work upon they are based on Revit elements. So before anything, you need to have Revit floor in this case already in place. Okay, so once you have floor in place, if you just go frame floor, so you can see service holes come as an option if you want to include them and how you want to spread them across. Bridging is sort of staggered, and all structural members are in place, just like I defined in the configurations prior to framing. Okay, so this floor is exactly the same. In this case, the floor is, I think it's a bit deeper, and I'm going to have bigger joists, wider and deeper joists spanning across. There we go. Bridging isn't going all depth, and you can see there's a little bit of difference how bridging is spread out. We have double joists at the end, and all remaining joists, I think, at 600 millimeters. All of that is customizable. Okay, and the last floor here, we're going to do exactly the same. Okay, so in this case, again, we have differentiated the spread of bridging according to bays. We have number of bays, and the two ones in the middle have cross bracing for the joists. The joists are doubled as well, and span direction is sort of from this end to that end, unlike other two floors we did. Okay, so what we can do with this floor further down, we can add some bracing. We can add bracing between joists. So we select joists opposite each other. The tool is going to add bracing, and we can just continue like that to add bracing. We can add bracing to external side as well. Okay, you get the idea. You can also add bracing throughout the entire floor, diagonally, or sort of a different variation of bracing. And we can also add corner bracing of joist as well. Okay, let's move to the floor that has two openings. Close this. And again, we do exactly the same. Click on frame floor. So this floor is framed. Again, we have openings. The way I set the configuration is a bigger sort of trimmer and headers to sort of frame around the openings, and you can spot the difference between other floors. Okay, in this case we're going to try to add details, so go to add modify bracing tab and go to add modify details. Well, let's just add details to the entire floor. All the details are customizable, same as all of the configurations that the floor would need to have defined. So you define configurations prior to framing, and then you just click on framing. Later on, you're going to split parts. At the end, you're going to produce shop drawings, and if you want, you can export to CNC machines as well. The detail is in place. This is again just a sample detailing. All of that can be changed. Again, it depends on your company standards, or it could be project instance. Sort of unique connection types. Okay, so connection is added as well. Right, so we're gonna go to the next floor that has 4 ducts, 2 on each side. So we're just gonna go exactly the same. I'm gonna click on frame floor. In this case, we're using I-joists with already sort of predefined service penetration holes. So if I-joists come with already cut penetration holes, you probably by then know that your ducts or any MEP service is going to go exactly there. So you set those distances in the when you are creating configurations, and again, all of that can be bigger, smaller, etc. That's all changeable. And again, you have the cross bracing all throughout. Okay, so that incorporates those ducts. Okay, right, so before we move to the next one, to delete a floor is a very simple action. So if you have this delete frame, click delete frame and just click any structural member of the frame. You can multi-select more than one frame and do it that way. There we go. Okay, so I'm just deleting those additional frames because when we move to the next frame, I'm gonna produce shop drawings for that, and to sort all elements, I'd rather have less elements to sort, so it's actually a bit faster. Okay, so then this one here, what we're gonna do first, we're gonna frame entire floor. You see this MP services running throughout the floor, and they don't necessarily have an even pattern. So this one is sort of leaning to the left. All other ones are straight. There's a junction as well. So now we have the floor framed, but the configuration didn't have penetration holes. So what we're going to do now is we're going to generate our interference checks. Okay, so collaborate tab, you have interference check. We're going to run the check quickly. We're going to go with ducts and pipes against structural framing. Okay, so Revit produces sort of a clash report, which we're going to export. Okay, say it's a desktop, name it AA. Okay, and now we're going to use cut opening that is part of AGACAD's Floor Plus pack. Okay, so we're going to read interference data first. We're going to find the file that we just exported. Okay. I'm going to save that data as XML just on the desktop as well. Okay, and when we go insert modify, insert openings, we're going to choose that XML file we have generated, which contains clashes of MEP services and structural framing members. Okay, so that's that report. You can sort of go into detail, but not this time. We're just going to insert and modify. So in this case, what it's actually doing is inserting all these openings where we had clashes. Okay. And we see that openings have been generated exactly where our services were, and I have left 10 millimeters offset from the actual duct. Okay. Right, so that's done, and we're gonna close this. So what we're going to do now is go to parts visibility on your left hand side, and you want to show both, which means we're going to be able to see structural framing. There's an actual Revit floor still existing there, and we're also going to see parts. Okay, so by splitting parts, what we're actually doing is we're laying our sheeting layers, so top and bottom sheeting. Okay. That's bottom sheeting, that's top sheeting. All of that is sort of, again, predefined before I did any framing or split parts. I've defined the sizing of sheeting. Okay, so we actually by now have entire panel complete with openings set according to our MEP services, and penetration holes are in place. So let's now number our floors before we produce shop drawings. We're going to number our parts and number all our structural framing elements, which could take a few seconds more. And once we have that, we can create assembly with this button here. By creating assembly, the tool automatically produces shop drawings. So all our shop drawings are going to go under Assemblies tab right here on the right hand side in the project browser. Okay, so you can kind of get a sense of what it's doing at the moment. Okay, so once all of that is done, we just need to make sure we select actual floor, and if we click on create assembly, so it's going to produce our views and schedules. It's going to place all of that on our sheets. It's going to tag all structural members. It's going to put dimensions as well. And all of that can be configured to your sort of standards. And once you have your sort of configurations in place that you sort of already working with in framing and splitting parts and creating drawings, those configurations are kept in your hard drive at all times. So the way the AGACAD tools work, we store the configurations, and I'll show you later. You can actually choose between the location of where those files are kept. You can have multiple sort of configurations in one project. Okay, so we see now assembly is in place, and if we go on the assemblies, F3, we're going to have a look at the sheet. Okay, so all of that is in place. I mean, there could be small inaccuracies, but once you set up your sheet template, you can reuse the template for the rest of your drawings, or produce multiple templates, of course. So here we go, our penetration holes are in place, sheeting both top and bottom layers are in place, dimensions put automatically. Okay, all those rules are again customizable. Each structural item is tagged. Okay, view is generated and placed on the sheet, and sheeting itself is in place. More than that, we have our schedules. Okay, there we go. So we'll go back to this view. All right, so we have still a few floors left to frame. So we let's switch back to original. So because I'm only framing the actual structural part of the floor, I'm not interested in parts. In this case, I'm just switching back so it's easier to sort of understand what is floor and what is a part. Okay, so we just select the floor again and click on frame floors. But didn't take too long, even for this one here. So we have double joists here, single joists there, bridging, etc. Okay, so I'm going to do exactly the same for this one. And those two other ones are metal, so I'll show you how metal frames work. Right, this one's done as well. Okay, all those structural members are cut and placed just where they need to be. Right, okay, so we go to metal framing, look for floor plus M. We're going to frame this metal floor. Right, this one is also in place. So again, bridging is sort of at the downside of the floor. Again, I mean, this is just a sample configuration that just shows you sort of the principle. Okay, and let's do exactly the same with this one. Service holes are in place. It's a different sort of type of bridging to joist intersection. Okay, right. So let's now see how we can split entire floor into multiple panels for prefabricated construction type. So again, let's just switch to both. Right. So my Revit floor is in place. I have a bit more context. Walls are framed, inner, outer leaves, and there's a basement going on as well. Okay, so select the floor and you view to split parts. So by splitting parts, I'm already getting my plasterboard ceiling layer, top and bottom sheeting, and in this case also flooring, floorboards basically. Okay, so in this case our parts are split. We have, as I said, floorboards in place. I have left 2 millimeters gap between each board, and they are placed just where they need to be. The opening is also included, and we're working it now. We're going to select this part in between, which represents our structural framing layer, and we're going to select all those 5 parts. What we're going to do now, we click frame. So we're going to frame those parts, meaning we're going to produce our structural framing in the place between 2 sheeting layers. Okay, so our framing is in place. If we switch to original, we're only going to see our structural framing. And that's our Revit floor. We can hide it for a moment. It's not advisable to delete it because you're going to need it later on. Okay, we can see how it's framed around opening. Again, we're using I-joists as our primary structural framing element. These are just more simple joists. Okay. So just an example, in the basement we have insulation in place, and on top of insulation is a layer of sheeting, and in this case is a parquet floor here. So again, all of that is customizable. The sizing, you can insert profile just like I did with the floorboards, and just work with that. You can also make tiles if you want, or any other type of flooring. Okay, in this case I have 400 by 400 tiles, and sort of a more traditional built on-site sort of floor type. Okay, battens, and there's our plasterboard. Okay, there's a metal frame, just a canopy. So let's now see how we can combine Floor Plus and Truss Plus functionality and generate metal and wood floor trusses and prefabricated metal floor panels for larger scale setting. Okay, so I'm going to switch to my other project. So quickly, just in this case, I'm going to show you how to sort of produce an opening in steel floor truss where we had a service coming through throughout some of the trusses. Okay, so what we're going to do now is we're going to go to ideally metal framing, Truss Plus M. Okay, so in Trusses tab, you go for Set Floor Truss Opening Position. It's going to ask you to select your service duct in this case, define opening width, and if you click OK, it will recognize which of those floor trusses clash with a duct and insert an opening just like that. So, and now we have an opening to sort of accommodate the service duct. Okay, right, so let's move to another scenario. Okay, so let's say you have a sort of a segment of your building, part of your building that say has a few columns, and you have different sort of structural variation or sort of different structural method going on. So I already have 4 truss layout lines in place, 2 on each side, which are going to support the floor above. Okay, and I will show you how to generate those floor layout lines. So I'm going to select all 4 of those at the moment, and I'm going to produce trusses in place of those model lines. Okay, I'm going to go to Trusses, Insert by Model Line. There's our library of all kinds of floor trusses with openings and without, etc. Okay, just let's go for any other truss. Okay, so in this case we have timber trusses are in place. Okay, so they are represented by analytical lines. Okay, if I click this one, structural truss, in the snippet you can see those analytical lines. You can of course change the view to just see the analytical lines. Okay, so those 4 trusses are in place. So what I'm going to do now, I'm going to switch to see both, and I'm going to split parts for my upper floor, the entire deck, actually. So the way I've created that floor, the bottom layer has sheeting, and also we have, if we frame the floor, sorry. Always make sure you select the actual Revit floor. Click on frame. So the sheeting layer is at the bottom, and top layer is where our trusses are going to go. And I'm going to have sort of I-joists as bridging. Okay, so I'm just going to multi-select those. However, 8 trusses. If you go to Insert by Selected Model Line, and just select the truss that you want. Okay, so our timber trusses are in place. We have a few more here. Those are just where they need to be. Okay, so for example, you have this family, this structural member is a family, and you have quite a lot of parameters to play with. Important one is the identity data. When you sort of sort your structural framing members, all of that gets filled in, just like we did prior to creating assembly for the floor panel at the beginning of the webinar. Okay, so all of that is in place. And what we also have here, I've modeled those strange floor panels that, well, I think they could be prefabricated and placed as sort of separate entities throughout the entire deck. So if I select all of those 14, and these are going to be metal panels. So if I go to Floor Plus M, Frame Floor, we have all our floors in place. So the other thing I wanted to do is split parts for those floors, because they have top and bottom sheeting layers. Okay, and all of that is in place. I mean, those sheeting layers can be configured to any way you like. They can be offset, they can extend, they can be 3, 4 layers. As I'm sure you understand, it's the configurations are limitless. Okay, if we cut through here. Okay, so all that is in place, and if I just drop down my section box, okay, we see more context, and as an instance of exactly the same workflow that was done producing the steel floor trusses. Okay, so again, you insert layout lines, and then upon those you build your trusses. The good thing about it that you can set your layout lines, and then if changes happen, you can easily redefine your layout before you even have produced single truss. And for example, when the layout is set, you can then start framing. One more example of timber trusses. Here, I mean, I appreciate those are long spans, they can be broken up. But just to give you an overview of timber version of sort of floor trusses, this may be a roof as well as floor. And the panels below, they look to be more like prefabricated timber panels. So as you already seen, Floor Plus brings the next level of automation to the entire design process. It ultimately reduces the manual labor to a minimum. Okay, so the best way to know if there's a software for you, or if you sort of, if your work, if the software fits the way you work, you can try it. So if you go to AGACAD's website, if you scroll down, you see free trials, and then here we have overview, getting started, and download. So overview just gives you a hint of how tools for BIM doc work, what it contains, and how you can update software and get all your e-help and support, online support for your product. And getting started is also going to explain you in more detail how all of this works. And download section will allow you to download the free trial to actually test the software for your Revit. It's 2019 and 18, I think 21 is on the way. And there's some instructional manuals. So thank you all for joining this webinar.
AGACAD, building BIM together.